Today we'll be talking about solving for quadratic equations, squares, roots, and theorems. Oh my. So what is a quadratic equation? A quadratic equation is an equation of degree 2, meaning that the highest exponent of this function is 2. So in this case, the highest exponent or power is 2 of this whole equation. This will be the general equation as well, and where a, b, and c are constants. So ax squared plus bx plus c equals 0. Now, the first part of this is square root. Now, a square root looks like this. It has a pointed, like a root. It looks a lot like a division symbol, but it's not really a division symbol because it has no rounded edge right here. So these are just different ways that we write it. This one has a 2 up here, and it's the exact same thing, which is why most people don't have that 2. And the other version is this one, where x is in parentheses, and you have the 1/2 power. And basically, it's just, the square root of x, or the half root of x. And it's saying the exact same thing as these two. A square root, however, is not this. It's not a tree, which is exactly why there's a red arrow or a red slash. So an example for a quadratic equation is letting x squared minus 4 equals 0. And basically we can add 4 to both sides, and we'll get the 4 cancel out over here and the positive 4 over here. So we'll have x squared equals 4. This is where the square root comes in. A square root is you take the square root of x squared and the square root of 4. And the square root of something is basically a number times itself. So what is that number? So the square root of something squared is just that number right here, x. And the square root of 4 is a number times a number. And so the only thing that can measure up to that, staying positive, is 2. So we have x equals 2. So, completing the square is something important as well. Completing the square is when we take where we take that general equation and turn it into a times x plus d squared plus e equals 0, where d is b over 2a and e equals c minus b squared over 4a. So, in this case, we are trying to find x. So we're going to let x squared plus 8x plus 16 equals 0, where a equals 1, which is right here, b equals 8, which is right here, because b is normally here, c equals 16, which is right here. It's just one constant. And we set that whole thing to equal to 0. So d is b over 2a, so we have 8 over 2a, which is 1, so we have 2 times 1. 2 times 1 is just 2, so we have 2 divided by 2, or sorry, 8 divided by 2. 8 divided by 2 is just 4. So we have d. So now we're looking for e. So we have 16 minus 8 squared over 4 times 1, which is the same as c minus b squared divided by, let's see, just 4 times a. So we have e equals 16 minus 8 squared is just 64. So, and then 4 times 1 is just 4. So we have 64 over 4. And so what's 64 over 4?
16.
Okay. So e equals 16 minus 16. 16 minus 16 is just 0, because the number minus itself is just 0. So now we have 1 times x plus 4 squared plus 0 equals 0. This is completing the square terminology. So if we multiply everything out and take away the zeros, we have x plus 4 squared equals 0. Now right here, what could we probably do?
Square root.
Okay. So, okay. We're going to go ahead and do the square root. there are other ways, but we're going to stick with the square root for now. So to use the square root, we're going to do a square root of x plus 4 squared equals square root of 0. Now the square root of 0 is a number times itself, so the only number times itself is 0. So that's 0 right here. Over here, the square root of anything times itself is just itself, so x plus 4 is inside the square, so x plus 4 equals 0. So now we have x plus 4 minus 4 equals 0, negative 4. So the reason for that is we want to get the 4 over here, so we subtract 4 from both sides. And 0 minus 4 is just negative 4, 4 minus 4 is 0, so x equals negative 4. Now, always check your work. So, almost always check your work. Check your work. So the original is x squared plus 8x plus 16 equals 0. So we're going to plug in what we found for x, which is negative 4. So we have negative 4 squared, remember we have to keep that in parentheses, plus 8 times negative 4 plus 16 equals 0. So negative 4 squared is 16. 8 times negative 4 is...
negative 32.
Yeah. Negative 32 plus 16 equals 0. So we're going to also try to get rid of... Actually, no, we're not going to do anything right now. We're just going to see what it looks like. So we have 16 minus 32 plus 16 equals 0. So we're going to go ahead and add 16 and 16 together. So we have 32 minus 32 still equals 0. 32 minus 32, any number minus itself, or is 0, sorry. So we have 0 equals 0. That's right. So everything makes sense. So x does equal negative 4. Now another one is the quadratic formula, which is for determining the roots of a quadratic equation from its coefficients. So we use this equation to basically summarize it. So x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Now how to derive it. So we start out with the general equation, and we use ax squared plus bx plus c minus c equals 0 minus c as the next step. The reason being we want to get rid of that c. So this equals 0, so we get ax squared plus bx equals negative c. Now we want to get rid of the a over here, so we're going to divide both sides by a, and this is what it's going to look like. Now ax squared plus bx over a is the same as ax squared over a plus bx over a. So we have this, x squared plus b over ax equals negative c over a. Now we are also going to add a new thing, which is b over 2a and squared to both sides. We're gonna add it to both sides. So over here we're going to have b squared, and we're just going to square everything inside it. B squared, 2 squared is 4, a squared, and over here we're going to have x squared plus b over a x plus, and we're going to keep this just as it is, but if you notice, this can all be turned into this, because this times itself, which is a square over here, equals this. So we have, and over here we're going to have 4a squared, b squared divided by 4a squared, and we want both numbers to have the same denominator, so we're going to multiply this by 4 over 4, because 4 over 4 is just 1, and 1's already right here, so we just have this is equal to this. So we have negative 4ac over 4a squared plus b squared over 4a squared, and this is the whole thing in parentheses squared. So that stays the same, but now we have this divided by 4a squared since it has a common denominator. We're almost there. So the square, and this is where the square root comes in. Square root of that big thing right here and square root of this big thing. So square root of anything, or square root of something squared is just itself. So we have this, and then the square root of 4 is 2, because we found that out before. Square root of 4 is 2. Square root of a squared is just a. So now we have x plus b over 2a equals plus or minus square root of b squared minus 4ac over 2a. Now, you have to remember that plus or minus because this could be, you can have a negative times itself still be positive. So we're going to have plus or minus square root of that over 2a. So here, we're going to subtract b over 2a from both sides. And notice that this has the exact same denominator. So all we have to do is combine these two. So negative b plus or minus this, and over here these cancel out. And this whole thing will just be divided by 2a. So we have x equals negative b plus or minus square root of b squared minus 4ac divided by 2a, which is the quadratic formula. So an example, we'll have 2x squared plus x minus 6 equals 0, where a equals 2, b equals 1 right here, and c equals negative 6. We plug those all into the quadratic formula and we get negative 1 plus or minus square root of 1 squared minus 4/2 negative 6 over 2 times 1, which is just 2. So if we do all that, we get negative 1. Over here we have 1 plus 48, whole thing over to 4. Right here we have, and so we get square root of 49, still over 4. Square root of 49 is just 7. So negative 1 plus or minus 7 over 4. Now we can go two ways with this. The first one is to let this be positive right here. So x sub 1 equals negative 1 plus 7 over 4. You add these together, you get 6 over 4, which is the same as 3 over 2. So x sub 1 is just 3 over 2. We also have this being negative instead of positive, so we have negative 1 minus 7 over 4, which is just negative 1 minus 7 is negative 8, sorry. Negative 8 over 4 is the same as negative 8 divided by 4, which is negative 2. So x sub 1 equals 3 over 2, and x sub 2 equals negative 2. And it would take too long to plug everything in. So we'll leave it here. Trust me, this is correct, but please do it on your own if you don't believe me. So what did we learn? We learned what a quadratic equation is. We learned how to use square roots in those quadratic equations, how to complete the square, and what the quadratic formula is. Now, why in the world is this even helpful? Well, you may use it in math, for instance, accounting, engineering, and construction, or you may not use it. You may not see this again after this year, or you probably will in future math courses, but the main goal here isn't to actually understand the math sometimes. Or it is, sorry. It's what matters is that you get used to seeing relationships between objects. For instance, the square roots, you're able to see, oh yeah, I can use a square root in a quadratic equation. And it's also to become familiar with just problem solving. All of this is problem solving, and in almost no matter what job you do, you will have to problem solve in one way or another. So learning how to do this is the point. So I believe that's it. Yep. Thank you. And that's it. Thanks.